Hello, I wanted to make a short video here to help you finish off the Projectile lab if you're doing it at home. So if you are able to successfully install Logger Pro, import the video, and collect your data, you should have 4 graphs that look similar to this. I have the X position versus time, the Y position versus time, the X velocity versus time, and the Y velocity versus time. Since these 3 graphs are already linear, all I have to do is put my regression statistics on there and I'm done with them. However, this graph is not linear and therefore I need to get a linearized version of it. This presents some special challenges and that's why I'm making this video. So I have inserted that video, my data rather, and a graph window on page 2 just so I can work with that one. So if I click on the axes on the left, I can select Y for that and then time here as well, and it doesn't look like it's scaled properly, so I'll click on auto scale and now I've got that same graph that I showed you on page 1. I could just work on it over here and not worry about the other ones. So hopefully you recognize that this graph is the graph of a parabola. A lot of times we see top opening parabolas. This one's a bottom opening parabola, but don't confuse it with a side opening parabola. So in order to linearize a graph like this, normally we would square the horizontal axis, which is time. So I'm going to go ahead and try that. I go up to the data menu, I choose a new calculated column, and so since I'm going to be squaring time, I'm going to type in time, and then I will put in a superscript of 2, so it's time squared. The short name could just be t squared. The units for time are in seconds, so time squared would be second squared. Then I would click down into the equation editor and choose from the variables column. It's important that you choose it from this column, time, and then to square it, caret 2. So I'm done. Doesn't change the graph until I change the axes, so I'll select time squared. And you see that this is not linear. So as we discussed in class, the reason for that is the technique of squaring the horizontal axis for a parabola only works if the vertex of the parabola is on the y-axis. It's not in this video, so we have to make some adjustments to get it there. So I'm going to go back to time so I can see this. And notice that if I have my cursor in the graph window, these numbers that disappear when I'm in the lower left corner, they are the x and the y coordinates, or in this case the t and the y coordinates for wherever this cursor is located. So I move it up close to the top where I think the vertex of my parabola is, and if I look down in the lower left hand corner, I see that the time coordinate is 0.604 seconds. Now I'm only going to work with the nearest tenth of a second at first, so I'm going to try and subtract 0.6 seconds from all of the time values, and that will have the effect of moving the graph over to the y-axis. To do that, I double click back over here on my data set on the time squared column so I can get this window again, and I'm going to subtract 0.06 seconds from these. Now the best way to do that is to enclose the variable time in parentheses. So I've just clicked behind the 2 just to get my cursor in there. I'm going to use my arrow keys to go all the way over to the left and put a parenthesis in. And then I'm going to use the arrow keys to go back between the quotation mark and the caret and put another parenthesis. And one more time, I'll use my arrow key to go inside the parenthesis but outside the quotation mark. And then I'm going to subtract minus 0.6. So now what's inside the parentheses will be whatever the time is, subtract from that 0.6 seconds, and then it'll square the whole thing. So I'll say done. Now of course it didn't change this graph, but if I go back to the time squared graph, I see that it did change it. I'm going to auto scale it, and you can see that it looks like 2 rays, one above the other. What I'd like to get is these 2 to actually line up on the same line. And this means that my guess was close, but it wasn't perfect. It never will be perfect, but I can get it a lot closer. So I go back to my formula by double clicking on the time squared, And let's say I'm just going to try, maybe this is a little too high, so I'm going to try 0.59 seconds. Say done, and they actually look like they're further apart, so that's a little worse. So maybe I should have gone the other way, and instead of 0.59 seconds, I'll go 0.61. I'll say done, and now I see that they really look like they line up close. Now I could go in there if I wanted to and try like 0.615, and I'm a little worse, and I could keep going back and forth like that until I get there. But 0.61 seconds seems like it passes the good enough test, and that looks pretty linear to me. So I'm going to put my regression line on there. If I make it a little bit bigger so that you can see what it says a little ways here, you can see that I have this linear fit. My slope is given as negative 4.4864 meters per second squared, and my correlation is 0.9999, which certainly passes the good enough test. So this is how I would linearize that graph, and this is the linearized version of my y versus t graph, and I'm ready to print it off and include it in my lab report.